ready for the end of the day so we can have math, right?
Yeah.
So let's do another one like you did, or like we did at the end. Remember, there are certain things that we need to know if we are sketching polynomials. One of the things that we need to pay attention to is what's the degree of the polynomial. And what do I mean by the degree of the polynomial? The highest power of x. So if it's x to the 5th plus 5x squared, blah, 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 it would be 5. You need to know the degree of the polynomial. Why? Why is that significant? Well, it gives you the number of roots to the equation. That's true. But what else does it give you, especially in terms of the graph?
How many curves?
Well, that's kind of related to his, but it gives you the end behavior of the graph. If you have an odd degree polynomial, then what you know about it? One's up, one's down. And the normal one starts down and ends up. But we know because of negatives, we can turn that upside down. Even degreed polynomials, x squared, x to the 4th, x to the 6th, even degreed polynomials start and end in the same direction, right? So we need to know that. Now, we also need to know something about the factors. So if it's an x to the 5th problem, it might have 5 individual factors, right? And each of those would be an x-intercept plotted on the x-axis. But some of those might not be individuals. Some of those might be squared or cubed. So you have to know how that alters the graph. What happens if you have a squared factor? The curve will bounce. There's like a parabola there, right? What if it's a cube?
Meander.
It meanders. We love that word. It meanders through the intercept. So your job is to find the degree of the polynomial, which is easy. You just kind of look at it and you have that. And then find the factors so that you know where to plot your intercepts and how to handle them when you hit them with your curve, right? Factors are important. Unfortunately, we usually don't have them. So we looked at one the other day, and tell me if this is the same problem we did the other day, stop me. If we don't have the factors, like we don't here, we need to find them. We need to find the factors. Now, one thing, you should always try to factor if you can. It's easier than all that guessing and dividing and all that stuff. So you look at this, and is there any factoring at all that we could do with this problem? We could take out an x. Don't not do that. Take out the x. Now, what does that tell you in terms of your graph? If you have a factor that is just x, that means what? Origin. This curve goes through the origin. One of your roots is x equals 0. When it is all by itself, it means 0. Now, look at what else you've got here. Now you've got a cube here that has to be broken down. The x I've already graphed. I'm done with that. Now I've got to take care of this. Does it appear that it would group? Now think what has to happen when you group. It does not appear to group. Now, somebody earlier looked at this problem and said, oh, but Mrs. Ford, what if we looked at these two terms and took out a 2x? And then what if we looked at these two terms and took out a 3? Is it possible to do that? Yeah. But what doesn't happen that needs to happen? The parentheses aren't going to match. So, it doesn't group. All right, so what do? Start guessing. Because our job is to find a number that when we plug it in, it gives us 0. Remember, you are looking for this point right here, which is something comma 0, right? want to find the number that you can plug in there that will give you a 0. Now, last time we were together, we talked about, okay, so we start guessing. All right, that could take forever. So we talked about a way to narrow down our guesses. The possible rational roots. I call them PRRs. You may have learned them last year, P over Q. It doesn't matter to me. You have to narrow down your options. Right now, I have the whole universe of numbers. I'm going to narrow it down so I have this little bucket of numbers. Now, what numbers are in my bucket? Factors of 15. It's last over first. So factors of 15 are what? Plus or minus? 1, 3, 5, 15. There they are, the factors of 15. Over the factors of 2, which would be plus or minus 2 and 1. So if I wrote these out in a list form, it is 1 over 1, 3 over 1, 5 over 1, 15 over 1. So 1, 3, 5, and 15. But then it's also 1 over 2, 3 over 2, 5 over 2, 15 over 2. So instead, you're looking at that thing, that's still a lot of numbers, Mrs. Ford, because it's plus or minus all those, but not compared to infinity, right? We've narrowed it down. So if I guess 1 and negative 1, which I always guess first, because they're, for me, the easiest, but they don't work. I guess 1, I guess negative 1, and they don't work. I'm going to skip 2 and go straight to 3, because 2 isn't in the list. These are the possible rational roots. If you're not in this list, you're not possible. All right, so I'm going to guess 1. So here's my problem. I'm going to put in 1. So that would be 2 plus 3. Oh, this is not good. That is not 0. So that doesn't work. I'm going to do negative 1 next. And if that doesn't work, then I'll jump to the 3's. But negative 1 is easy arithmetic. So negative 1 will be negative 2 plus 3 plus 14 minus 15. That could be 0. It not only could be, it is 0. So we have found a number that when we plug it in, it gives us 0. That means that my factor, I had my original x, now I have a factor of x plus 1. Would you agree with that? If the 0 was negative 1, the factor was x plus 1. So what's my next step now? I guessed and I found one that worked. What's my next step? Divide it out. Divide it out. And when I divide, I'm dividing out of here. So I'll go through this one more time, and then I'm going to, this is another thing, that if you don't know how to do this, you got to get in here. I'll do it one more time. I put the number I'm dividing by, which is negative 1, the number that gave me 0. The number that gives me 0 goes out here in this little box. These are the coefficients of the polynomial. This number gets dropped straight down, always. Now we multiply negative 1 times 2 and write the answer here. Add. Negative 1 times 1, write the answer here. Add. Negative 1 times negative 15, write the answer here. Add. Did that have to happen? Yes, because that number is the remainder. And if you are telling me that this is a factor, factors divide in evenly, right? Okay, what's next? Take this guy, he's called the depressed polynomial. Take him and try to factor him. I'm running out of room here. So you've got 2x squared plus x minus 15, does that factor?
Yes.
How?
2x minus 5 times x minus 3.
Let me check, is that right? Yep. So what are the other dots I'm putting on my graph? I've got one at -3, and I made that one up, remember, and I have one at, we're close, 5/2. Everybody okay with that? 4 dots, 4th degree. Nothing squared, no repeated factors, so that means when I start connecting the dots, I'm just going to zip my way through. Should I start down here, or should I start up here when I start drawing my picture? Where do I start? I start up here?
Here, yeah.
Because this is a 4th degree positive. Starts up, should end up, let's see if it does, down we go. Connect all the dots, I keep missing them. And there it is. Now, I've drawn it kind of nice. We don't know how far down these go. They probably don't go down the same amount. One of them's probably longer than the other one, but that's irrelevant. You want that W shape, you're good to go. Everybody okay with that? Now there are a couple of things that can complicate this, and you're thinking, oh my gosh, look at all this, Miss Floyd, this is a huge problem, and it is. You need to know a lot of things to do it, but there are a couple of things that could complicate the situation. So let me give you another problem. And we're going to do it exactly the same way, but something is going to happen that's a little bit different. Alright, so same directions, we're going to sketch this. So what's the first thing you think when you look at this problem? Think grouping. That is what I want you to think. I want you to think, can I group it? So don't like waste 15 minutes on it, but kind of look at it. It doesn't appear to have grouping potential. Would you agree? 6, 7, and 4 don't seem to be good numbers to have. All right, so now what? PRRs, you're thinking, oh great, I'm going to have to guess. This time it's not so bad. What are your PRRs? Plus or minus?
1, 2.
1, 2, and 4. And that's just over 1. So literally, it's plus or minus 1, 2, and 4. So instead of having all the numbers, you only have 6. All right, so here we go with 1. 1 work? No. -1? Okay, so we're going to go to 2, I guess. No, that doesn't work either, does it? Keep an eye on my arithmetic. Oh, no way is this going to work. Well, shoot it 2D, but I guess we're up to 4. 4. Actually, I think that works. I think that's my 0. But actually, Dylan, they don't have to. Now, I know what you're thinking, and it's a good point. You're thinking, this is 4. Fundamental theorem of algebra states that this problem's going to have 3 roots. So, if you're telling me these are the possibilities, then something better work, because I'm supposed to have 3 answers. Yeah, here's the thing. See this R right here? The P stands for possible. This stands for rational. So if there are rational roots, they are in this list. But the roots could be imaginary or irrational. And that's what we're going to deal with, I think, in this problem. I'm hoping I got the right problem. Before did work. So that means one of my factors is x minus 4. It means one of the points on my graph will be at 4, 0, right? All right, so what do I do now? I've got one of them guessed. What do I do now? Division. So out here we'll go to 4, and I have 1, negative 6, 7, 4, and I'm going to go ahead and do my division. Again, if you need extra help with the division, you need to come see me. There's that 0 in the remainder spot. Good, 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 because we said this was a factor. What's left? X squared minus 2x minus 1. Doesn't factor. Well, darn it. We're still going to graph it. We need to figure out where those other dots are, but they're not going to come from the factors. So how are we going to figure out where those other dots go? We're going to use our quadratic formula. Now, would the calculator give us the zeros? Absolutely. But we're not going to do that. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so underneath there I have what? The square root of
Square root of
8, which is 2 root 2. Does that simplify it all? Yeah, it does. We got 1's all over, so it'll be 1 plus or minus root 2. So my other 2 roots aren't in this pile. There they are. Why are they not in this pile? They're not rational. All right, 1 plus root 2 decimally is about 2.4. So for purposes of plotting, I'm just going to make that a decimal, round it off to 2.4. That's 1 plus root 2. And 1 minus root 2 would be about negative 0.4. So if your depressed polynomial does not factor, all hope is not lost. You'll just use your quadratic formula, get your irrational roots, and plot. Now, this is a cube. Nothing squared on any squared factors or anything. So where does it start? Down or up?
Down.
It starts down, heading up. And there you go, you've sketched it. No big deal. What's the matter? Well, the only way things bounce is if one of your factors is squared. This is a cubic polynomial, and there are 3 dots up here, so they're all single zeros. It's a little hard to do 3 individual parentheses because I rounded these off because they were radicals, but that would be the format, 3 individual parentheses, no squares.
Because of the answers that there would be like a two-shirt of twice.
Yes.
You don't put anything in the other pairs?
Probably not, Jay. Normally what we would do is put this up there because that does not factor into separate factors. So normally we wouldn't do that.
So you're going to put
Yeah, that's what we would do normally. Now, again, our purpose here was to sketch this. That was our end goal.
So that doesn't matter.
No. Now, we need the factors to do the sketching, but this one didn't factor, so I had to deal with it this way. Okay?
How do you know when you start down and end up, or start like?
Can anyone answer that question? She says, how do you know that I start down and end up?
If it's negative.
If it's an odd polynomial, Annie, odd polynomials start down, end up, period. That's just what they do. You will remember that because you have already memorized the cubing function. That's an odd polynomial. That's how they act. Now, they have other squiggles and things in the middle of them when you start adding more stuff to the problem. But fundamentally, end behavior is the same. All right, I have one more that I need to do. Wait, no, I don't know. Oh, is this the long period?
Yeah.
Okay.
We're gonna have homework time? Do the new one.
What?
You have to switch it to the new one.
The new one, what?
The one you said you're gonna do.
Yeah, I'm gonna do it right now. I have it on my paper. I just have to figure it out. Okay. All right, so here we go. We're gonna look at this one. And then we're gonna go to our book and look at some of these sort of random, weird types of problems they put in there. All right, so here we go. Last one of these, where the job is to sketch it without a calculator. Sketch it. Okay, so what's the first thing we do when we look at the problem? Can it group? Well, this one has a lot of terms. Grouping would be a little tricky, and I don't see it happening with this combination of numbers. Nothing looks too good that way. So I'm going to guess, and what are my PRRs going to be? 1 plus or minus 1, 2, 3, and 6 over 1. So basically, plus or minus 1, 2, 3, and 6. Right? Okay. I need everybody in here to pick something, guess, and try it. Let's see if we can find one. So pick anything from that list. 1 works. Somebody said 1 works. All right, let's see.
Oh, I didn't do it. It does. Oh, it does?
Yeah, 1 word.
1 works.
Yeah, it does work.
It does work. Good job.
Thanks, guys.
Okay.
So, if we did synthetic division with the 1, if you do the same thing, right?
Yep, it's the same thing. I like to plug in because it takes less room than synthetic division. But if you want to divide every single number until you find one that gives you a remainder of 0, that's absolutely fine. That will work every time. It just takes a little more space. All right, so now I found one that works. Oh, and I'm going to keep track of it over here on my graph. So since 1 worked, that means I have an intercept at 1, right? And I have a factor of x minus 1 if I'm keeping track of the factors. Okay, so now I'm going to divide. Good news, got my 0. Right? So now what? Well, what's left here is what? Be careful. What's this? X cubed. Oh, Lord. That means we're going to do it again, folks. Because this does not factor my grouping. Would you agree? That's what I have left. And it doesn't factor my grouping. So we're going to guess again. Now, do we have the same PRRs we had before? Oh, yeah, we do. Yeah, we do. Factors of 6 over factors of 1, right? So we do the whole thing again. Now, here's the thing I want you to think about. If, okay, 1 worked. Could 1 work again?
Yes.
Yes, it could be a repeat factor. So don't be afraid to try it again. However, this particular problem is a little special. Remember, your goal is to get 0, right? Look at all those positives. Can you stick a positive number in there and get 0? Use your logic. Don't you have to have some negatives in there if you're going to end up with 0? So I'm not even going to try positive 1. I'm going to try negative 1. And I think we have another winner. Cassie, love, what's on that iPad? Whatever it is, it's making you smile, and I know it's not Precal. Right? So unless you're using that for math, I need you to flip the lid down. Thank you. It makes me smile. All right, so now negative 1 works. So now I have a factor of x plus 1, and I have a root of negative 1. Everybody still with me?
Yeah.
All right, what do I do now? Divide it out. Now, when you divide it out, don't go back to the original. Go back to the one that you were using. So we're going to divide negative 1 out of this. There's our 0 that we knew we were going to end up with. I know, Clark, there's a lot of steps here. It just keeps going. But wait, because this is good. Now we're getting to the exciting part. All right, what's left? X squared plus x plus 6. Now, when you get it down to a squared, you don't have to guess anymore. Because that will be quadratic. Obviously, that's quadratic. And you'll either factor it or use the formula, right? So take a look. What about that one? It doesn't factor, does it? Jade?
I just have a question. Oh, never mind. I figured it out.
Good. Good. Okay, does this factor? No. So we're going to use our quadratic formula. Here we go. X equals negative b plus or minus the square root of b squared. Oh my golly. What happens? We get imaginary roots. Now, I want to back up a minute. This problem has 4 answers. Positive 1, negative 1, and these 2, whatever they are. Only the real numbers can be graphed. So these are imaginary. Everybody agree with me? They're not plottable. Those are not plottable. So now you got to draw this picture based on just what you know. Because these points aren't going to help you. So what degree do I have? 4th. So where should this curve start? Up. Okay, up. And then it should just go right through here, right? And then it should come up and go right through that one. Now something's missing in that picture. I don't know exactly, and we're going to do it on our calculator in a minute to see, but right now, I don't know exactly what this thing looks like, but look in your notes. We did a 4th degree equation earlier. What shape did our 4th degree equation have? It was a W. Now, see these 2 roots? They have an impact on the picture. They just don't hit the x-axis. So, the picture could look like this. Do you see what I mean? This doesn't dip down far enough to intersect. It might look like that. I have no way of knowing. That would be an option. So if I'm sketching by hand, I could sketch that. If I'm sketching by hand, I could also sketch this Would that be another option? And if I'm sketching by hand, I could also sketch that. Would that be another option? This is going to be a W, all right? It's going to be a W. I just don't know where the W part is. Is it over here in this quadrant? Is it up here in this quadrant? Is it in between my two zeros? I don't know. The best I can do is say, okay, it's one of these pictures. Okay. I forgot I had that already in there. The best look like that. That's the best I can do. So let's go to our calculator, let's sketch it and see which one of those it is. Which one of my possible shapes is it? Go back to the original equation, yes, all the way back to the original equation. Put it in. And if I put this on a test or quiz, it will be accidental because I want you to graph what I give you, and you can't graph this by hand. But if I were to do that, it's an accident, then you would have one of these three pictures. Those are the possibilities. The only way to know is to actually plot points or use your calculator. So which one did you come up with? None of those?
No, I'm not gonna say anything. It's a straight line.
It can't be. It has to have a loop in it.
What do you have to do?
I don't know. I haven't done it yet.
That's what I did.
I don't know what window I have set. I just press graph. All right. You know what? Oh my gosh, I can't believe it, but it might be parabolic. Some fourths are, but boy, I did not think this one was. It is crazy. You learn something every day. Nope. It's parabola, it looks like. Remember that hidden behavior we talked about? I'm searching for it right now. I'm not seeing it. I'm also not seeing a parabola. It's got kind of a parabola shape, but I don't think it has symmetry, does it? It's not, it's parabolic, but it's not a parabola, but it's right. I'm not seeing any weaves either. I'm seeing something that looks like this. Okay. All right. Well, there you go. I'm not going to spend any more time on it, but that's, I don't see the W shape in that one. It came out to be kind of a parabola, which x to the fourths can do, but not usually with all this in there. So, I don't know. Learn something every day.
It's like a W if you look at it from this angle.
Okay, we'll go with that. The point is, though, kids, if it's a fourth degree polynomial and you can only find two of the roots, you can't graph it by hand unless you physically set up a t-chart and plot a whole bunch of points. So I'm not going to ask you to do that on purpose. It could be an accident, I suppose, but not on purpose.
So you won't give us one like this on purpose?
I may ask you to solve it, come up with the roots, but not graph it. No, not graph it. Okay. All right. Now, let's get our books out. We have a little bit more time. And let's look at a couple problems in our book on page 209. All right, keep working on the W. Listen. While we have our calculators out, get your head up, Charlie. While we have, this is the best period of the day. Seriously, where else can you grab right? All right, number 20, page 209, number 20. Page 209. Number 20. Page 209. 20. 2.3. Problem 20. Problem 20. Sometimes our issues are not in the actual problem, but in reading the directions. Our job is to find a viewing window that shows all of the extrema and x-intercepts, and then describe the end behavior. All right, for number 20. Now, before I even go to my calculator, I can describe the end behavior of that function. So can you. The end behavior, you'll recall, is the limit as we go to positive infinity and the limit as we go to negative infinity. Number 20, what degree? 3. What do we know about third degree polynomials? They start down and end up, right? Now, I don't know about what's happening in the middle because I haven't graphed it yet, but I know for sure it's down here and up here, correct? That's the end behavior. So as we approach positive infinity, what happens to my curve? Positive infinity. As we approach negative infinity, negative infinity. When we do an odd degree polynomial, won't you always have one of them positive and one of them negative? Yes, because why? They go in opposite directions, right? All odd degrees go in opposite directions. If this had been an x to the 4th polynomial, what can you tell me about these? If it had been x to the 4th, they would either both be positive or both negative, depending on whether we had a negative in front of our thing or not. Right? That part's easy. Now, did you type the equation in and hit graph? Keep in mind that what you need to see, according to the problem, are the x-intercepts and the extrema. You need to see the x-intercepts and the extrema. What do we mean by extrema? Tops of hills and bottoms of valleys. So, your job is plain and simple, make the window so that you can see your x-intercepts, top of the hill, bottom of the valley. All right, anybody got a window that shows that yet? David?
The x minimum is -10, x max is 10.
All right, so stop right there. David says if he uses a regular, the standard kind of x dimension, -10 to 10, he can see how many x-intercepts, David?
3.
Yeah, this is a cubic problem. He needs to see 3 x-intercepts. He sees them. Good. All right, what y's?
Y min is -100.
Okay.
And max is 150.
150?
Yeah.
He says if he uses those dimensions, he can see the top of the hill and the bottom of the valley. Is he right?
Yeah.
Okay. Now, does that mean that if you have something different, you're wrong? No. There would be lots of numbers we could put here that would allow us to see the top of the hill and the bottom of the valley, right? Your job is to figure out a set of numbers that works. That's easy, okay? So let's look at another problem on this page. 29 to 32. Matching. Now, as you look at the pictures, a couple of things need to pop through your head. First of all, pictures A, I'm looking at 29 to 32. Pictures A and B have something in common. They're both odd degree. So when you're matching equations, you're going to look at A and B as odd degrees and C and D as even degrees. All right, so A and B must be either 29 or 30. So how are we going to know which is which without actually graphing it? Do you have an idea? I mean, without actually like graphing that equation. I'll give you a hint. Look at the y-intercept. Look at your equations. If you put in 0 to equation 29, you get a positive 55. If you put in 0 to equation 30, you get a negative 18. So look at your pictures. One of them has a positive y-intercept, and one of them has a negative. I'm looking at the cube pictures. So A goes with 29, and B goes with 30, because B crosses the y-axis at a negative number. So the y-intercept has to be negative. Okay? Now, what about C and D? Can we use the same logic? C has a positive y-intercept, so C must go with 31. And D goes with 32. That was easy. We've already done a ton, so we're not going to do any more, but when you look at the directions to 33 through 38, and it says find the zeros of the function algebraically, that means factor or do this procedure that we've been doing. It means no calculator. That's what that means. All right, number 50. We know how to do that. 52. We know how to do that. So we're good on that page. Oh, we are so good. All right, let's take a look at on page 223. Last topic of the day. If we get through this, I'll shut up, but we got to get through this. All right, so I'm on page 223. This is section 2.4. And I'm looking at these directions for the very beginning of the problem. And we're going to do number 2 together. It says divide f by d. So that would be x cubed minus 1 divided by x plus 1. And write a summary statement in polynomial and fraction form. All right, so I'm going to do that for you. I'm going to show you what that means. But first, we're going to do this division. So we are in section 2.4, doing problem number 2. No, we're starting it. And we've done parts of it because 2, 3, 2, 4, and 2, 5 overlap hugely. If I were writing my own book, it'd be one section. Now, first step, divide. All right, we've been dividing all morning or all afternoon. So we're going to put a -1 out here in the box. Is that okay with everybody? Out here in the box goes the number that you plot. And if you were going to plot this, you plot -1. So that goes in the box. Now, be careful here. 1, 0, 0, -1. Now, why do I have those 2 zeros in there? Because the x squared and the x terms are both missing, right? Okay, so now I'll do my division. Okay, first of all, check my arithmetic. There's a lot of 1s floating around in there. Did I do okay? Is that okay? Now, what do I know about this? It is not a factor, right? Why not? It has a remainder. Okay, so now I'm going to write my summary statement. Okay, my summary statement is simply what you just did. So x cubed minus 1 divided by x plus 1 equals, okay, what does it equal? What's that going to be? X squared minus x plus 1, right? And then plus negative 2 over x plus 1, because this was the remainder. And think about in regular arithmetic, if you are dividing, what does that 1 mean? I mean, when we were a baby, we wrote remainder 1. Remember that, like back in 2nd grade or something? But now, what does that represent? 1/3. So when I do this division, my remainder is over my divisor, what I divided by. So this is your summary statement. That's all that means. That's your summary statement. So your quotient and your remainder. All right, so that's easy enough. What about number 5 though, kids? How do you do number 5? No idea? Well, Mrs. Ludington and Mrs. Hollis would not be happy to know that you have no idea. You can't do it synthetically. What's different about number 5? The thing we're dividing by in number 5, so we have x to the 4th minus 2x cubed plus 3x squared minus 4x plus 6. The thing we're dividing by is not a polynomial, or not a binomial. So, oh yes, I know, I don't like it either. But unfortunately, it's the only way to do it. So, we gotta get through this. Everybody take a deep breath. Do a jumping jack if you need to. Here we go. Anybody remember how to get started? Yes, that's exactly right. Cassie says, how many times does x to the 2nd go into x to the 4th? Or, another way to think about it is, what do I have to multiply times x squared to get x to the 4th? And that would be x squared, right? Isn't x squared times x squared going to give me x to the 4th?
Yes.
So I'm going to take that guy times all of these. So I get x to the 4th plus 2x cubed minus x squared. What do you think? Is that okay with everyone?
Wait, why did you put over there? X squared?
I like to have everything lined up. It doesn't matter. The answer is going to be up there. It doesn't matter where you put that. I like it. To me, it looks better. But that's just a fashion thing, not a math thing.
Can you just like multiply that by like multiplying?
Yep, that's what you do. That's what you do. But you figure out what you're going to multiply by doing what Cassie said. Because whatever ends up here has to cancel this out, baby. Okay? So I couldn't put x cubed up there because that would give me x to the 5th. I have to get what matches it. Now, once I've done that, I'm going to subtract. And before you say, why are you doing that? Think about regular long division. Think about regular long division. You put a 3 up here, and then what would you do? Subtract. It's the same process. So I'm going to subtract. So these are gone. They have to be gone. These are not gone. It's negative 4x cubed plus 4x squared. And then I'll bring down my next term. If you want, you can bring it all down. It doesn't matter. Now I start over again. What am I going to put up there? So when I times it by x squared, I'll get negative 4x cubed. Negative 4x. No, I want them to match. They got to match exactly because I'm going to subtract them. So I get negative 4x cubed, negative 8x squared, and positive 4x. Everybody still with me?
Yeah.
Now what do? Subtract. And if these don't cancel, you're wrong. They have got to cancel. And they did. So what am I left with? 12x squared minus 8x plus 6. And now we start over again. What do I have to put up there so that when I times it by x squared, I'll get 12x squared plus 12. So 12x squared plus 24x minus 12. Now what do? Subtract. Here they go, they're gone. And I'm left with negative 32x plus 18. Now wait a second. I'm done. I can't go anymore, can I? So what do I do with that? That's the remainder. So I'll come up here and say plus negative 32x plus 18 over x squared plus 2x minus 1.
Is that it?
And we're done. Is this a factor of this? No. Why not? Because we got a remainder. If you get a remainder, you're not a factor. Oh my gosh, did we learn today?
It's like Spanish.
Better than Spanish.
It's like Spanish to English.